Hello friends, welcome to H2 Abundant Academy. In this particular lecture, we will discuss about the simple harmonic motion. So let's begin. So what is a simple harmonic motion? Simple harmonic motion is a kind of motion in which particle moves in a straight line in such a way that its acceleration is always directed towards a fixed point. Okay, so it is a kind of motion in which acceleration at any particular point is always towards the fixed point, and that fixed point is known as a center of force. And this acceleration at any particular point varies as a distance of that particle from the fixed point. Okay, so let us understand this with the help of a diagram. So this is a straight line and we have the center of force as O. This is the center of force. Center of force. Okay, and we have the extreme points as A and A dash. Okay, so let us consider a point P here. This is a point P. So we have the motion. Let us consider the motion from A to O. Okay, so let us consider the motion from um, A to O. So in this particular direction, we are having a motion. So we are considering the motion from A to A for the time being. Okay. So what will be the acceleration at point P? So by definition, the acceleration at point P is always directed toward the center of force. So in this particular direction, the acceleration is directed by the definition of the simple harmonic motion. So the acceleration at point P is given by d2x upon dt square is equal to minus mu of x, and we are taking the negative sign here because the acceleration is in the direction of x decreasing. So from A to A, the x is getting decreased from x2 is equal to A to x is equal to 0. So there is decrease in the value of x. So we can say that the acceleration is in the direction of x decreasing. So we are taking a negative sign here. Okay, so we have the acceleration as d2x upon dt square is equal to minus mu x. Okay, and what is this mu? Mu is called the intensity of force. Intensity of force. Okay, so the higher the value of the mu, higher is the intensity of the force, and with more force, it is being directed towards the center of force. Okay, as simple as that. So let us move further. So we have the acceleration as d2x upon dt square, and this acceleration is proportional to x. This means x is equal to x is the distance of particle from center of force. Okay, so x is the distance of the particle from the center of force. So this is x. So the value of x is this. This is the value of. So this acceleration at point P. Suppose this acceleration is a dash. Okay, so a small a dash is proportional to x by definition of SHM. Okay, so let us read this. So we have simple harmonic motion is a kind of motion in which the particle moves in a sorry the particle moves in a straight line in such a way that its acceleration is always directed towards the fixed point on a line called center of force, and varies as a distance of the particle from the fixed point, and this fixed point is known as center of force. Okay, so this fixed point is center of force and varies as the distance of the particle from fixed point. This means acceleration is proportional to x, and x is the distance of particle from center of force. So this is the value of x. X is the distance of this particle. So at P there is a particle. So distance of particle from O is x. So this distance is x. So this acceleration is proportional to x, and we have acceleration x double dot is equal to minus mu into x, and we are taking the negative sign because the acceleration is directed towards center of force and it is in the direction of x decreasing. Okay, so let us move further. Let us move further for the calculation of velocity at any point. So let us find the velocity at any point. So we have the straight line like this. Okay, this is center of force, x is equal to 0. This is the extreme point, x is equal to a, and x is equal to minus a. Okay, so we have to find the velocity at x is equal to x. So let us take a this point P is at a distance of x from the center of force. So we have to find the velocity. What will be the velocity at point P? Okay, so we have the acceleration as by definition acceleration at point P is proportional to distance of this proportional to suppose this is O. This is proportional to OP. So we have acceleration is proportional to x. OP is equal to x. And since the acceleration is directed towards center of force and it is in the direction of x decreasing, so we have acceleration is equal to minus mu into x, and mu is called the intensity of force. Intensity of force. So we have d2x upon dt square equal to minus mu x. Okay. So let us multiply. Let us take this as equation 1. Let us multiply both sides by 2 dx upon dt. So we have 2 dx upon dt into d2x upon dt square is equal to minus 2 mu x dx upon dt. So this we can write as d of dx upon dt का whole square is equal to minus this is equal to minus d of mu into x square. On integrating, we will get this value. Okay, so let us integrate both sides. So we have on integrating both sides with respect to t. तो ये क्या आ जाएगा अपने पास? What will we will get on integration? Let us integrate this. So on integration, we get dx upon dt whole square is equal to minus mu x square plus c. Okay, now at x is equal to a, at x is equal to a, velocity is equal to 0. Okay, because at point A, at x is equal to a, we have v is equal to 0 because motion is from A to A and the motion gets started from A with a 0 velocity. Okay, because particle is at instantaneous rest at A. Okay, so when x is equal to a, v is equal to 0. So let us put this here. So we have this as dx upon dt is v. So v will be 0. This is 0 is equal to minus mu into a square plus c. This means c is equal to mu a square. So we have dx upon dt whole square is equal to minus mu x square plus c की value mu a square. This is equal to mu of a square minus x square. So we have dx upon dt as dx upon dt whole square is equal to mu a square minus x square. So we have v square is equal to mu a square minus x square is the velocity at at a distance x from center of force. Okay. So we have to find the velocity at any point. So velocity at point P is given by v square is equal to mu a square minus x. Okay. So let us now find the point of maximum velocity. So we have the relation between velocity at point P and displacement x is given by v square is equal to mu a square minus x square. So this is let us plot this. So we have the relation between this is our this is v and this is x. So this is a inverted parabola. So we have the like this. Okay, so this is x is equal to a, this is x is equal to minus a, this is x is equal to 0. So at x is equal to 0, at x is equal to 0, v is equal to v max. Okay, so v max, let us put, so putting x is equal to 0 in equation 1, so v square is equal to mu into a square minus 0, v square is equal to mu a square. This means v is equal to root under mu into a. Okay, so here we have v is equal to v max, and at x is equal to a, at x is equal to a, so let us find the point of zero velocity. So let us equate equation 1 to 0. Equating equation 1 to 0. Equation 1 to 0. So we have 0 is equal to mu a square minus x square. This means x is equal to plus minus a. So at extremities of motion, that is at x is equal to a and x is equal to minus a, we have velocity is equal to 0. So here velocity is 0 and velocity is 0 is v is equal to 0. Okay, and v is equal to max at x is equal to 0. So we have the point of maximum velocity at center of force, 0 velocity at the extremities, that is x is equal to plus minus a. Okay, so now let us find the maximum acceleration and 0 acceleration. Okay, so let us find this. So what we are having is that the acceleration is proportional to x, that is distance of point from center of force. Center of force. So we have d2x upon dt square is equal to minus mu into x by definition of SHM. Okay, so acceleration is max when x is equal to plus minus a. So this is our motion. So this is center of force, x is equal to 0, and these are the extremities. Okay, so we have the motion from A to O. Okay, so considering this motion from A to O, we have the A max at acceleration maximum at x is equal to a. So we have so acceleration is maximum at x is equal to a. So we have d2x upon dt square maximum is equal to mu into a. This is magnitude of maximum acceleration is mu a. So we have at x is equal to a, we have acceleration is equal to minus mu a. Okay, this is directed toward the center of force. Common manner, acceleration is equal to mu a. The magnitude of the acceleration is mu a. Zero acceleration, so at x is equal to 0 from this equation, if we put x is equal to 0, then acceleration is 0. So acceleration is 0 at x is equal to 0. So let us jot down this. What we are being asked, maximum velocity, 0 velocity, maximum acceleration, 0 acceleration. Okay, so we have the motion like this. So this is center of force and this is the extremities. X is equal to a, x is equal to minus a. So maximum velocity. So at center we have v is equal to v max, and at extremities we have 0 velocity, because we have the relation as v square is equal to mu a square minus x. So at x is equal to a and x is equal to minus a, velocity is equal to 0. So v is equal to 0 and v is equal to 0. And at x is equal to 0, we have the velocity as root under mu into a. So this is equal to root under mu into a. This is v max. Now this is done, this is done. Maximum acceleration. So we have the relation as d2x upon dt square equal to minus mu into a. So maximum acceleration when x is equal to plus minus a. So this is a max and this is a max. Maximum acceleration is mu a. Zero acceleration, at the center of force we have zero acceleration because the velocity, there is no change in velocity at point O. So the velocity is V max is equal to a acceleration is equal to change in the velocity. Okay, so the change in velocity is zero at the center of force. So here we have acceleration as zero. Okay, so let us move further. Displacement at any particular point. So we have the motion is like this. Okay, so this is center of force and this is x is equal to a and this is this is the extremity. So we have here x is equal to a and this is a dash. X is equal to minus a. So we have to displacement at any particular point. So let us consider a point P here. So we have a point P here. So we have to find the acceleration at point P. We have to find the acceleration at point P. So we have the equation as we have to find the displacement at point P. Displacement at point P. How we can find the displacement at point P? So we have the relation as v square is equal to mu a square minus x square. So we have dx upon dt whole square is equal to mu a square minus x square. So we have dx upon dt is equal to plus minus root under mu root under a square minus x square. So we have the motion, the velocity at point P is in this direction, in the direction of x decreasing. So we have dx upon dt is equal to minus root under mu root under a square minus x square because we are considering the motion from A to A and the um, velocity is in the direction of x decreasing. Since velocity is in the direction of x decreasing, so we are taking negative sign. So we have dx upon dt is equal to minus root under mu a square minus x square. So from here we have dx 1 upon root or minus 1 upon root under mu dx upon a square minus x square root under is equal to dt. Okay, so let us integrate this. So on integrating we are having so we have dx upon a square minus x square under root minus this is equal to cos inverse of x upon a. So we have 1 upon root under mu cos inverse of x upon a is equal to t plus constant of integration d. Okay, so let us put limit. So now at x is equal to at t is equal to 0, initially at t is equal to 0, we have x is equal to a. So we have 1 upon root under mu cos inverse of a upon a is equal to 0 plus d. So 1 upon root under mu into cos inverse of 1 is equal to d. Cos inverse of 1 is 0, so d is equal to 0. So this equation becomes, so now we have this equation as, let us put d is equal to 0. So we have this as 1 upon root under mu cos inverse of x upon a is equal to t. Let us further simplify this. So this we are having cos inverse x upon a is equal to root under mu into t. So we have x upon a is equal to cos of root under mu into t. X is equal to a cos root under mu into t. This is the x is the displacement at any particular point. Okay, let us move further. So that the time of descent is independent of the initial displacement. So we have the motion like this. So this is our center of force. This is center of force. Okay, so our complete oscillation is like this. So this is the starting point. This is the complete oscillation. So the time of descent is like from here to here. Okay, so this is T1. So let us take this as A and this as O and this as A dash. So time of descent is time of descent. Time of descent is time taken by particle from extremity to the center of force. Center of force. So this is the time, that is time of descent is T1. So the total time taken by the particle to reach from A to O. This is the total time T1 from A to O. Total time taken by the particle. And we have the motion like this. So the complete oscillation is like this. From A to O, here O to A dash, then A dash to O, and then O to A. This is the complete oscillation of the simple harmonic motion. So the total time period capital T will be 4 times of T1. And T1 is the time of descent, that is time taken by the particle from time taken by the particle to reach from the extremity to the center of force is time of descent. So let us find the value of T1. So we have the velocity as dx upon dt whole square is equal to mu a square minus x square. So we have dx upon dt is equal to minus root under mu root under a square minus x square. So I am taking the negative sign because the velocity is in the direction of x decreasing. So we have 1 upon root under mu minus cos inverse of x upon dx upon root under a square minus x square is equal to dt. Okay, so let us put the integration here. So we have at this is x is equal to a and this is x is equal to 0. This is t is equal to 0 and this is t is equal to t1. So at t is equal to 0, we have x is equal to a, and at t is equal to t1, we have x is equal to 0. So let us put this. So 1 upon root under mu cos inverse of x upon a. Let us put the limit as x equal to 0 and x equal to a is equal to t1. So we have 1 upon root under mu cos inverse of 0 minus cos inverse of 1 is equal to t1. So this is 1 upon root under mu into cos inverse 0 is pi by 2. Cos inverse 1 is 0 is equal to t1. So we have t1 is equal to pi upon 2 root under mu. This is the time of descent, and obviously it is independent of the initial displacement because there is no component of x here. Okay, so the time of descent is a constant value. Okay, because intensity of force is also constant. Hence, we can say that the time of descent is independent of the initial displacement. Okay, so let us go through the nature of the motion. The motion is in the straight line. This is center of force. This is extremity. X is equal to a. This is x is equal to minus a. Okay. So we have the particle starts from the rest at a. So here particle is at rest. That is v is equal to 0. Where its acceleration is maximum. Acceleration is maximum here because there is a maximum change in the velocity at x is equal to a. It begins to move toward the center of attraction. So it begins to move towards center of attraction, and as it approaches the center of force, the velocity goes on increasing. The velocity goes on increasing in this particular direction, and it is Vmax at the center of force. Maximum value of the velocity is at the center of force. So the velocity goes on increasing in this particular direction, and here we have velocity is equal to 0, and at center of force we have Vmax. Okay, when the particle reaches O, its acceleration is 0, and here acceleration is 0 because there is at center of force there is no change in the velocity, and its velocity is maximum and is a root under mu. So V max is equal to a root under mu in the direction of OA dash. In this particular direction, this is O and this is A dash. So in the direction of OA dash, velocity is there. Due to this velocity gained at O, so there is some velocity that is being gained at O. The particle moves towards left of O. But on account of the center of attraction, a force begins to act upon the particle against the direction of motion. So the direction is motion is this, and by definition, the acceleration. At suppose we take a point here, okay. So at this particular point, the acceleration is directed toward the center of force by the definition of simple harmonic motion. So this is written here. But on account of the center of attraction at O, the force begins to act upon the particle against the direction of motion. So the direction of motion is this in this particular direction of motion, but acceleration is being directed towards the center of force. Okay, but the velocity goes on decreasing and it comes to an instantaneous rest at a dash. So this is our a dash, and here velocity becomes 0. Okay, the particle at once begins to move toward the center of attraction, and retracing its path, it again comes to the instantaneous rest at a. Thus, the motion of particle is oscillatory and it continues to oscillate between a to a dash to start from a and come back to a, and this is a complete oscillation. How there is a complete oscillation, let us show this. So this is our complete path. Okay, so let us look at the movement of this yellow marked pen. Okay, so this is the starting point. So particle moves from A to O dash. Sorry, particle started from point A and it has moved to center of force O. Now again it moves from O to A dash. Now again it returns back to O, and finally again it returns to A. So this is the complete motion. This is the complete motion. So here we have V is equal to 0. Here we have V is equal to maximum value. V is equal to 0. Acceleration is maximum. Acceleration is 0. And acceleration is maximum value. Okay. So this is the complete oscillation. So what is the amplitude in SHM? The distance from the center of force of the position of maximum displacement is called amplitude. Okay. So this is center of force. Center of force. This is the position of maximum displacement. Displacement maximum. X is equal to A, and this is X is equal to minus A. So by definition, magnitude is this particular distance. Okay. So distance from the center of force of the position of maximum displacement. So this is amplitude. Similarly, this is amplitude. So this is the maximum displacement. This is center of force. दोनों के बीच का distance क्या होता है? Amplitude. Time period. In SHM, the time taken to make one complete oscillation. So we have the complete oscillation is like this. This is the starting point. So from here, A to O, A to O, O to A dash, from A dash to O, now from O to A. So this is the complete oscillation. So suppose this point is time of descent we have calculated. This is T1. So this will also be T1. This will also be T1. This will also be T1. So T1 we are having as pi upon 2 root under mu. This we have already calculated now. Time of descent is T upon 2 mu1. This is time of descent. So the total time period will be 4 times of T1. Total time period is equal to 4 into T1. This is 4 into pi upon 2 root under mu. This is pi upon, this is 2 pi upon root under mu. So we have time period is equal to 2 pi by root under mu. And this time period is independent of amplitude A. Okay. Now let us find the frequency. The number of complete oscillations in 1 second is called frequency of the motion. Okay. So time taken in complete oscillation. Complete oscillation. complete oscillation is equal to 2 pi upon root under mu second. Okay. So the number of oscillations. So let n be the number of oscillations in 1 second. N into 2 pi upon root under mu is equal to 1 second. This means n is equal to root under mu upon 2 pi. This is equal to 1 upon time period. This is 1 upon t. So n is equal to reciprocal of time period. So number of oscillations in 1 second is called frequency of motion. Let us read the important results. This we have already discussed. Refer to the center of origin. The equation of SHM is d2x upon dt square is equal to minus mu into x. Negative sign is because the acceleration is always directed toward the center of force and it is in the direction of x decreasing. Or the equation x double dot is equal to minus mu x represents a SHM with center at the origin. Velocity v at a distance x from center and distance x from the center. So v square is equal to mu a square minus x square. This we have discussed. X is equal to a cos root under mu 2. This is the displacement at any particular point x. A is the amplitude and t has been measured from the extreme position in the positive direction. Okay. So we have t. This is the starting point. This is the starting point. This is a. This is o, and this is a dash. This is the starting point. So t is measured from the extreme position. So this is the extreme position. This is also the extreme position. So t is measured from the extreme position in the positive direction. Okay. Maximum acceleration is mu a. This we have already seen. Maximum acceleration mu a. This we have already seen. Maximum velocity is root under mu into a. This we have already seen. Time period is 2 pi upon root under mu. Okay, so we will discuss problems in the next particular lecture. Okay, thank you.